much that slows it down.
Probably less than photo.
Yeah. All right, so maybe I'll only open Photo Booth when I need it. That didn't really do anything. Okay, so we should hopefully know how to create paths, how to get stuff in. Talia, you're at the moon, right? The today's tutorial or whatever, or last night's tutorial. You were able to go through it.
No, I didn't.
Okay. Okay. So then you'll have to copy. You'll have to go here. Follow me up here. So go to your wherever you have the WebGL book code. Man, it just fucking kills my computer. Yeah. And let's go to chapter 3, and then go to Earth Moon JS. And if you open that up, it should have Earth App, Create Globe, Create Clouds, Create Moon, all this type of stuff. Sun, Moon is down at the very bottom, right? So just Apple C that file. Just the Earth Moon JS.
Yeah.
And then go to your class test server and go to public. And then go to Talia.
Yes.
And then just paste it in there. earthmoon.js. And then go back to WebGL book. Alright, so then go back to WebGL book, go to chapter 3 again, go to graphics earthmoon.html, copy that, go back to the class server, into Talia, into views, because this is an HTML file. Yeah, so go into views, paste it in there, and then say get info. Right click it and get info, and change the HTML to ERB, hit return. It'll say use ERB or you keep HTML. I want to use ERB, so then that'll change it. No, get info. And go down to main. Delete HTML. Use ERB. And then in your root directory, or in your app.rb right here, create like a path like get Earth Moon or get solar system, just so that.
Is that just Tyler or we all?
You should already have this path because we did it last time. Yeah, in the moon. And then do ERB inside of it that says the exact name, like Earth. I think it's like, what is it? Graphics. Shit. Graphics, Earth, Moon. And then leave off the ERB. So turn that off. And then actually go in and change it so that there's no dashes. No, just take out the dashes so it's all the words are just smashed together. And then also do that to ERB space : graphics Earth Moon with no. Yeah? and then save it, and you're running your server. So do solar system or whatever you named it for the path. And then you'll probably have problems. Yeah, so let's see what the problems are, because JavaScript console failed to load resource. The server responded with the status 404 for earthmoon.js. So you'll go into here to views, and you'll go to graphics earth moon, and then you'll change these. So this is your .erb file.
Yeah, I just.
And you'll just take off all of these dots. And then you'll put on the earth moon JS, you'll put /Ryan or /Talia /earth moon JS. And then you'll reload it, and there'll probably be other problems. Or no. Perfect. So go to your, you should. So it's,
Yeah.
so this is all of this stuff?
This is
Okay, cool. So go in here and just take those. And then put slash Talia slash, and then save it. And then refresh it.
Yes.
Cool. All right. So, if you have at the top of your thing, if you have /js /build/3min.js, throw that out and just put /lib/3.js.
Why do we get changed?
Because he did it on a very old one, and the code that we're about to fill in is on an old one, so we're going to need to change it up.
I have my 3JS at the third one and it still works somehow.
No, that's totally fine, but the code inside of your 3JS is not the code that he's accessing. So you have to change which library it's looking at. So it'll be /lib/3.js. And it'll be capital 3.js. Unfortunately, I
And I should
apologize.
keep doing it in the same file we were doing it yesterday.
Yeah, so you'll just use the exact same file. Oh, wait, no, you can't. Shit, everybody should have done that. Exactly what she did. Otherwise, there's going to be different.
Explain to me.
What happened? Did you set up a folder like this and then class test server? Or
Yeah,
did
you
you just put this?
So like
You can do
what
either
you
way.
told me,
But where it is doesn't matter.
I mean, this is better, right? I that was a mistake. I thought.
Yeah, no, that's fine.
That's
totally fine.
It's kind of redundant though, isn't
So I
it?
have to make it
I mean,
new,
it,
a
either or
new-
is not going to change.
That's
It's fine.
Right, but where did you get graphic arts? Like you just made
It
a
was
new file?
HTML out of chapter 3.
Yeah,
Oh, I
so
should get it from.
yeah, so the WebGL. So
But I don't have Java.
you should. I think everybody does. So go to WebGL book master 2. Everybody should do this, by the way.
Chapter 2 or chapter 1?
Chapter 3. And then grab earthmoon.js and grab graphics earthmoon.html. Grab both of those, copy. We're gonna put them in 2 different places, but just so that we don't have to go all the way back.
Sorry. So.
Earthmoon goes in Pati.js.
So earth-moon.js goes in Pati, and then graphics earth moon, this one goes in your views like this.
Oh, and I can't just do it by throwing it into Sublime. I have to throw it in the Finder. Right?
Yes, correct. Yes, and then just throw these things into their respective places. I just put this here, so I'm going to replace it. But basically, we want to just, and then once you have them where they're supposed to be in views, change graphics-earth-moon.html to graphics-earth-moon, no spaces, no nothing, .erb. And the easiest way to do that is right-click and get info, and then go and change it actually in the name and extension. It'll ask you like, yeah, do you want to do this? And you will say, shut the fuck up. I'm gonna fucking do this if I want to. I fucking say what.
Sudo do this.
Yeah, sudo.
I just made a nerd joke.
No.
You're hired.
I'm so hired today, aren't I? I'm like hired as I'll ever be. So we only do those two, and now in apps we have to make
A new
A new
path.
path.
Yeah, a new path. So we'll all start out at the exact same place.
what are we gonna call this?
Solar system, because we're going to be adding a lot of stuff.
Or we're going on full solar.
Yeah, we're going to full motherfucking solar.
I think the planets, nah, spheres.
What do you want to make them? Stars?
I want to make this old and efficient.
Yay! You were inspired by last night's movie. So I'm gonna link it to. So I link it to Graphic Arts.
So that's the name now. You just changed it.
All right. So
Okay, Ryan, why is there no camel case on graphics opening?
you can put camel case if you'd like.
You can't?
Yeah, you can do whatever you want. This is just like basically this is your world. You can do whatever you
I
want.
was dying. I was dying without that camel case.
Yeah, I was like, no. Said nothing.
So we're gonna do a lot of crazy code,
Oh, it works.
and we're gonna create some Saturns, and we're gonna create all sorts of stuff.
And then we just have to change in here, right? We have to link it to the appropriate.
Yeah.
Why do we link it to Earth Moon? The
Check
Earth
it,
Moon is doing the
change.
same shit we did. It's exactly the same file.
Yeah, it's exactly the same file,
Yeah.
except it's using old code.
Right, because I did it and it's like giving me the same thing.
Yeah, no, totally.
Oh.
Yeah, so, but it's using old code, and there's stuff that we're going to use in this that I haven't gone through and like repaired to the new version, so we're just
So I
going to
should
use
just-
the old version.
I'm gonna put these away.
Yeah.
Now we're gonna work on these together.
Yep.
Slash the name of the file.
All right, so we've seen our Earth and Moon,
Yes.
It's solar system is a way.
and now we will talk about what's going on.
Show
All right, so let's do this so I can.
Also change, yeah, it's so change it because it's now.
Um,
Two things.
We're still in chapter
yeah. What am I going to look for? What is it that oh, photo booth.
custom geometry page.
Yeah, so we're going to do some crazy custom geometry. All right.
Do we still have to do our midterms tomorrow?
Yeah.
But I mean, I was able to use captions.
Oh, you can? So I'm gonna think against gaps.
All right.
Okay, let's do this, because it's 9 and we still have to do our midterm and...
Yeah.
We're doing it.
Okay, are you good? Are you set up?
I mean, what is good?
Are you set up?
What is good?
All right, so today we're going to create something that isn't just right out of the box in Three.js, where it's not just a sphere, where it's a very easy calculation. We're going to create our own specific custom geometry. So like this was another thing that was like really super incredibly exciting when I figured out how to actually create planes and triangles and stuff without using like just draw a solid sphere basically. And it all has to do with mathematics. It's all mathematics. So just like everything, we're going to start with a grid just to like give us an idea of where we're at, and let's pretend that this is all one, right? Are you set up?
So turn
We're gonna post this video tonight.
I'm gonna try it.
it.
Yeah. All right. So how do you make a plane? This is like one of those things where I was like, I will never actually know how to do this, like because it's just too hard. It's too conceptual. I don't have any idea how to connect a lot of vertices into one big object. But it's actually incredibly easy, and I just didn't know at the time. So let's say that our origin is 0, 0, right? Like it always is. We put a point at 0, 0, right? Then we traverse up 1. So now our point is 0, 1, right? And then we go over to a point right here. That's 1, 1. Then we come down here. This is 1, 0, right? And then the only way to connect this as like a plane where you can get a color so it looks like, you know, like the side of a cardboard or this, is to connect it into triangles. So we connect it into triangles counterclockwise like this, and then like this. Counterclockwise like that. Does that make sense? So let's say that we start with this point. 1. This is first point that we create, put into our buffer. This is 0, 1, right? And then the second point is down here. We come down, 0, 0, okay? Follow me on this. And then the third one is here, and the fourth one is here, okay? So the only way that GL will ever understand why this should show color or texture or anything is because we have to tell it, okay, now that you have these 4 points in memory, how, like, because it's like, okay, well, I got 4 double numbers. That's all I know. I've got 4 double numbers. So what we have to do is we have to actually tell him how to connect those numbers. So if you remember, we used face 3s. And that was because we had 3 dimensions. We're going to use face 2. We're going to pretend that there's like a face 2 and that there's a reason to use it, just because it's easier to talk about in this space. But basically, if you'll remember, face. Let's just talk about 3. Let's pretend that these are z is 0. Basically, it's like right on the plane. So we'll use face 3. So let's pretend that we buffered them in this exact order, right? So now we have to tell, now 3JS knows about these 4 points, but it doesn't know how to draw them and in what order. So what we have to do, and this becomes very algorithmic, is we have to say, okay, well, I know that the first point I want to draw first, and the second point I want to draw second, then the third point I want to draw third. So easy enough, 1, 2, 3, right? So we tell it, like, you'll have at least 1 point. Or actually, let's say 0. Let's say 0. 0, 1, 2, 3. 0, 1, 2. Okay, so first triangle is done. Boom, boom, boom. Now 3JS knows how to draw these 3 points. Right? It understands, okay, I'm going to take this one, then I'm going to draw a line to this one, then I'm going to draw a line to this one, and then I'm going to like do some crazy shit to like interpolate like what it should look like across this. But it's not as easy with this triangle, right? It's not just 1, 2, 3, because it's the opposite way, right? Everything's going around, right? So what we do, I mean, what in essence it is 1, 3, 2, right? Now, what's great about this is that this is exactly the same structure for every quadrant you make. Every single one. So in essence, you could imagine that let's say my algorithm, so everybody kind of understands this, can picture this in their mind. My algorithm for generating this, and let's just flip it, like, because it's easier to think about flip. Like where, 0, 0 is the origin, but then 1 is down, just so that it's easier to think about. So in essence, what I want to do is say for int x equals 0, x is less than, say 640, right? 640 and x plus plus. So this takes care of one point at every single pixel, 640y, right? The next for loop, the inner for loop, is going to be for int y equals 0, y is less than 480, y plus plus, right? So now that will take care of every single point for one pixel all the way down the y-axis, right? So now all I have to do, what? Not necessarily. We'll leave it in xy for right now. So now what I can do is I'm iterating over every single position, right? And this position can be given as 3, pretend that this is capitalized, 3 dot vector 3 x, y, 0, right? So now, in essence, what we have stored in here is going to be one vertice per pixel of like an old television set, basically. So now what do we do? How do we tell it, like, algorithmically, how to connect those triangles in exactly the way that it wants to connect those triangles? Because that's kind of hard, right? That's a little bit hard. What were you going to say?
I'll wait.
Okay. So what we're going to do is we're going to create more vertices each time. We're going to create one whole quad every single for loop. So in essence, the easiest way to do it is to create all 4. Now we know we have 4 that have been stored, and then we'll create a phase 3 for both of the triangles. Does that make sense? So in essence, we're going to say 3.vector3 x, y, z, or 0, and then we're going to say, we're going to add another one, 3.vector3 x plus 1, y, 0. So now we've created this one. So we've already created that one. Now we're going to create this one. Now we're going to create 3.vector3, x, y plus 1. Let's say that, again, let's flip. Yeah.
That's why
Exactly. Sorry. No, sorry. Yeah. You were exactly correct. Yes. So x plus, or y plus 1, right? So now we've created this.
Yeah.
And then we're going to say 3.vector3 x plus 1, y plus 1, 0, right? So now we've created the fourth one, right? So in essence, in this for loop right now, we've created these 4 points. Well, we're only going by 1, and we don't want to double up on points, so all we have to do is just say, well, we're covering, we're covering 2 points in each for loop, so we'll just increment 2, right? So x plus equals 2 each time it jumps. So we'll come to the next point, basically. Does that make sense? So now how do we say do this? Well, we say 3.vector, we've got to create an index, right? So now we understand how to create all 4 points, but now how do we get these 4 points going? Well, it's as easy as saying how many points do you have right now, subtracting 4, which gives us a new index, and then subtracting 3, which gives us the second to last index, 2 to give us the third index, and 1 to give us the final, the last one that was done. And in essence, it's like, so let's say that this is vector 3 is an array, right? So we can get a number, a length back of that array. So if we subtract by 4, then we can get each of these indexes. So for instance, this would be 0, this would be 1, this would be 2, this would be 3, right? So we can just use those to create the indexes where we'll, let's say that we subtract by 4. Let's say we just subtract by 0, right? And so we get the number which is the index of that point. So this, let's say this is ID 1, and this is ID 2, this is ID 3, and this is ID 4. So now we have the location of, like, basically it's like for this, it's going to be 640 times 480 points, right? So we'll get the ID in that array of points of what this point corresponds to, right?
Oh, because each point has the 3.
Because each time through the loop, we've added 4 on. So if we subtract by 3, 2, 1, 0, then we get these numbers, whatever they may be. For the first time through, they'll be 0, 1, 2, 3, right?
Because we've added 4 times the length of that
Exactly.
slide.
Exactly.
So
So then we can just easily programmatically understand that this plane, this quad, is exactly like this quad, is exactly like this quad, is exactly like this quad. I always want to connect whatever this point is to this point and then to this point. And then I want to connect whatever this point is to this point to this point. And so you can basically, like, there's your programmatic. You say 3, and again, pretend that I'm not capitalizing, but 3 dot face 3. This is too far over. 3 dot face 3. And every single time through the for loop, through the multiple for loop, you'll do ID 1, ID 2, ID 3, and then you'll create another one because you have 2 that you created each time through. And you'll do face 3, and then you'll do ID 2, ID 3, ID 4, ID 3. Every single time. So that will connect the last 4 to create another quad, basically. So if you do this, I mean, I think actually I have to flop these. Y needs to be the outer. Then basically you will have a 640 by 480 vertice on, like, buffered as numbers and easily readable by the GPU and manipulatable in any way that you want to do, all set up and ready to go. So in essence, you can, with a little bit of math, you can create any shape you could possibly think of. You can create donuts, you can create, what is the Ouroboros, or, whatever that thing. Yeah, Mobius strip. You can create spheres, you can create everything. Just like this, exactly like this. It's just basically knowing like how far you've jumped, what you've jumped, and how to connect those three. Go ahead.
Those indices, though, are you going to write the math up there?
Oh, right, to get the indices. So let's say that I haven't actually screwed around with 3JS's version of this, but I assume that there's something like three, like, let's say that we want to create a variable. So in between vector 3, like adding those 4 vectors and putting the faces on, we'll do something like this. We'll say var id 1 equals, what is it? Well, no, it's like 3 dot vertex. I can't remember exactly the 3 dot vertex or vertices dot length minus 4 or minus 0. Does that make sense? Or yeah. So the length. So it's basically because we've already added a new one. That would be the last one. Does that make sense? Yeah. Go ahead.
These are not. Are we pushing back vertices into a vertex list?
Yeah.
Oh, okay. I think you didn't mention
Oh, sorry.
that.
Yeah, so whenever you do the 3 dot vector 3, you're putting them into a geometry.
Okay,
Buffer.
geometry vertex. Or
Yeah.
Geometry vertices.
And we're gonna see in code how to do this.
Yeah.
And it'll make a lot more sense. And then you do var id2 equals 3 dot vertex dot length minus 1, and then minus 2, and then minus 3, and you've got your IDs of where they sit in the vertexes. Does that make sense? A little bit? Yeah, go ahead.
Maybe I'm just confused. I'll leave it if I draw it. So you're doing this, and you're skipping 2. So if you start and you have, say, 1, 2, 3, so you have 0, 1, 2, 3. Right. So you make these, and then like that, and then you skip to 2.
But
Isn't this what's happening? What about this one? Because it's
going here. Oh no, because whenever I skip to 2, it's like.
Are you just adding?
It's like these points are now already inside
Right.
of the thing.
Because you
So
make
whenever
it
I
this one.
subtract the length, it will then ID these things. Does that make sense? And then you leave off the last one.
Oh.
You leave off the last one. So you're like jumping and you're subtracting by 4.
Yeah, and that leaves you these ones, starting here.
Yeah.
So you're actually indexing like. Well, that makes sense though. But it's because you put these 4 in, but then you subtract 4, so you're back here.
Well, let's actually let me really quickly because when I figured this out, it was in
Is
Cinder.
your question why you're implementing?
Well, no, I know why we're. Well, yeah, I guess exactly. I guess that would be my question. Why implement by 2 instead of?
It
1?
might be 1. It might be
Because
1.
if we do 1, then it puts us back here, but we already have a point there.
Yeah, exactly.
So we want to only add these.
No, I think that's it. It's because you plus 2 and then you use the vector. Let me look what I did in Cinder. All of the math will make sense in just a second. So, sorry guys. Let's go. Test. Xcode.
Are you done?
We're just getting into thicker.
What?
So let me wait until this opens.
We're having like, this is like the most important thing.
It
And
is.
it's
It
still
is.
like when no, we're doing this. We're talking about how to generate triangles in mesh. So you can define ideally your own plane of any shape and index it properly so it'll connect with the right triangles and not be all totally batshit crazy like this, which is like really.
All right, so here's kind of the math of the thing. So triangle quad size is 10. So I'm jumping 10 every single time, but I'm also only adding 10. So yeah, no, it is exactly, oh, sorry. Yeah.
So it's 1, not 2.
How do I, yeah, it's 1, not 2, correct.
So it's one, so it's the same, so it's one, then we're going back to the same dots?
Yeah. So you are, but you're,
0, 1, 2, and then 2, 4, 1.
oh, and then you don't add
Four.
a last one.
If it does it for you?
Yeah, because like the math works out to where it does it for you. So here's basically this math created this. Hopefully it's working. Sorry, it's running real slow.
You guys are gonna see a lot.
When?
In a month, in the group from the live.
So this will create this. So you can create like mountains and all sorts of crazy stuff.
That's beautiful.
Let's go Barros.
So I can show you how it looks like without the sine wave that I'm doing down here. But basically, so that's just being erupted by Z. Once I get all the vertices in there, then it's like sine wave, FFT data. But
And you have like a lighting video?
no, it's actually just it's just color manipulation. Yeah, booyah. And I'm starting to mess with noise maps, but I haven't actually played with it in a while.
You guys have that picture.
So this is like what it looks like without all of the Z. It's basically exact. So the color is kind of weird, but that's just because of the sine wave. Yeah, but this is like just a basic quad with 640 by 480. And the way that I jump is by 10 steps each time. So I create the first vertice would be 0, y would be 0, 0, and then this would be 10, and then 10, 0, and 10, 10, right? Then y is 0, x and y are still 0, so I'm going to jump to 10.
For 1 unit size.
Yeah, 1 unit size over, and then create the same ones where now it's going to be 10, 10, 10, and then and you can get past this. Like I could actually create a different way of indexing where I would not have to jump 10. I could jump 20, and then use the last 2. But the whole thing is that it's kind of weird when you're jumping to get like the indexes correct, because now you've added another 4, but you still have 8, or you basically have 8 indices, 8 vertices to connect in the second one. Does that make sense a little bit?
Right.
Because if you jump 2, then you still need to connect this inside. So I jump 1 and then make 2 new points that are basically the same as the old points. But you can optimize it in a way. But more than all of this is to understand that like this is just anything that I decide. like what I've written on the board is anything that I decide. This could be like, let's say that this is Z space, so like here's this point, and then here's this point right here, right? And then I want this point back here in Z space, and I want this point up here in Z space, like this. So like, I can mathematically do this. I just have to like understand that these, every time I make 4, I can give them any value in the world. But anytime I make 4, I have to make sure that it understands 6 different indexes. Does that make sense? Like I have made 4, so now I need to connect them in the correct way. Does that make, kind of make sense? Okay, so let's go into making this stuff. Allie, you should go and grab this. So watch me on the screen. If you go to WebGL Master or wherever you have the WebGL book code, and go to chapter 3, and then select earthmoon.js and graphics earthmoon.html. Copy those and then put them in your class test server, the JS inside of your public folder and the HTML inside of your views folder. Create a new path to it, and then so in app.rb. So you'll move, and then graphics earthmoon.erb. You'll have to change this by like right-clicking and getting info, because it's HTML right now, and then just take off the HTML and take out all of the dashes. So it looks exactly like this. Graphics earthmoon.erb. But don't try to do it in the Finder, because it won't let you rename the HTML. Yeah, get info and then rename it in there. And it's going to be like, are you sure you want to change from HTML to ERB? And you're going to say, yes, I do want to. And then in the public, alley file, you'll put the earth-moon.js file. And then make sure that all of your class test server is open. In Sublime Text, like just drag the whole class test server into Sublime Text, and then go to the graphics earthmoon.erb and change the script to these scripts. So I think it's all like ../libs, ../libs. Just take out those dots, and then at the very end where it says earth-moon.js, just put your name /alley/earthmoon.js. Does that make sense?
It does.
Totally. Yep. Let's check it out.
Am I not connected properly on
It doesn't look like it's. I'm not on Shotgun. It. Install. Maybe moving it doesn't know. Oh, you moved it back. JPEG bundle install. Yeah, I just needed to re-update it. Now it should shotgun. What?
Just take out the dot.
Yeah, just it should be /libs all the way down, then /sim, and then right here where it says earth-moon.js, it should be /alley/. And then shotgun config it and open it up in your browser to make sure that everything works, and then we will get started. And let me know when you get it.
for the ERB, can I just change the ERB to that file name? To the Earth,
What?
to the Earth Moon JS, I just changed that little ERB.
Yeah. And then you should save it. So yeah, we take out the graphics that's the ELB itself. No, you don't. And then save it and open it up in the browser. See. Slash out. Cool. All right, so here we go. Let's code. Let's get coding. We are gonna so code. All right. So first off, let's make a new file in your directory. That new file is going to be called Saturn.js. Save. And then you want to make sure that you save it in your specific folder. And then pull this over. Now I'm going to have to look at, because he doesn't really go over all of the code in the book, because it's some rinse and repeat, but I want to go over it because I think everybody should get into that code. So, I'm going to have the code basically up, but just follow along with me as I write it. So first off, we are going to create a new custom Saturn class. So we've created classes before. It's as easy as just creating a function that acts as a constructor of the class. And we're going to do what we always do, sim.object.call this. So again, this is just saying, hey, I'm going to be a sim object. So will you add everything that sim object has to me? Give me all of his luggage. I want to make sure that I can travel like him. And then we'll say, and then we'll say Saturn.prototype. And then we'll say new sim.object. So now Saturn is truly a sim.object. And then we're going to say Saturn.prototype, so we're going to add a new function to Saturn's prototype. It's going to be called init, just like every other one. We're going to add a function in there, and we're going to say param inside that parameter. We're gonna pass some parameters inside of there. And then this is one of those crazy JavaScript things. We're gonna say param equals param or empty object. So if I don't put anything whenever I'm initializing Saturn, it's going to know param is nil. So you don't want param to be nil. So it's going to do this like basically this branch. It's like an if statement. If param is not nil, then go ahead and put param inside of param. If it is, put an empty object, because we don't want param to be nil. Because later on it's going to need to do some things, and if it gets accessed in a weird way, it'll throw crazy errors. So it's just another one of those things. You could think about it like in Java, we overload functions, right? So like, you could say like update with this param, or update with this param, this param, and this param. And it basically, it's in the runtime, it's going to decide, oh, did he call one with 3 params, or did he call one with only 1? Okay, well, I'll use whichever function he's talking about. Like, I'll make that decision during the runtime. And JavaScript just makes it a little bit weirder, because it's basically like, you can put in 1,000,000 parameters, and as many as you want to fill in, I'll take. But the rest I'm going to make nil. So basically it's like, this is like a catch. Like whenever you're functionally programming in JavaScript, you have to make sure that the stuff that you're going to use later on or add things to isn't nil. It needs to be something. So this is basically safety guarding the fact that I might not put in something in it. I might just want the regular functionality. All right, so var planet orbit group equals new 3.object 3D. So why do we make object 3Ds? Yeah. Yeah, you can do transformations. It's basically just like putting a lot of things into one array. So I can add objects to this now. And in his framework, this .set object 3D basically says, what is my array of objects? Go ahead and give me a pointer to those objects so that I can access them outside of here. And then we're going to make another group called planet group equals new 3.object 3D. So now we're making another array. And you could imagine that, planet orbit group, we're going to add planet group down here. But we'll get to that in just a second. Var distance equals param.distance if param has something, or 0. Does that make sense? So now you can see that like above this call we could say like var Saturn. So like don't type this. I'm just saying like pretend we're an Earth app and we're initializing all of our stuff. We could say var Saturn equals new Saturn parentheses. Then we could say Saturn dot init and then we could pass it an object that says distance, and then we could say 400, right? And then we could say size, and we could say 35. So like basically this object is saying I'm going to make some key value pairs, and whenever we get into here, it'll check to see like, oh, did he put a distance key? Okay, he did. Then I'll put that value inside of the distance inside of here. So you might think to yourself like, how the fuck would you ever know that these options existed? Well, whenever you're like creating these, applications, you are designing them. So you say, okay, well, I want something that I can quickly and easily put a bunch of keys into, like a bunch of values into. So I'll create this parameter that is an object, and I know that it's an object. So now every time that I use this init function, I know that I can pass it in objects. So like, let's say that we're not creating Saturn. Let's say that we're creating 100 million particles, right? Those particles could be given programmatic sizes based upon whatever I decide generatively that I want. Well, they could have sizes, they could have colors, they could have all these types of things. So the way that I would do that is basically I would say, var particle equals new particle, right? And then particle dot init, I know that I've designed this to where it can take, programmatic color. So I'll say color, new gen color, and size, new gen size. Or I could make a branch that says sometimes I'm going to want to deal with the size, and sometimes I'm going to want to not deal with the size. So I'll say if deal with size because of something else that I have defined myself, like, oh, sometimes it needs to be this default size. So right now I want it to, so I've made deal with size true, or you know, whatever. And then in here I don't add that. So now these two different lines, though they're basically doing the exact same thing, in essence, I can programmatically decide while the program is running what stuff I want to give to this initialize function. Does that make sense? Cool. Quick little programming thing. All right, so let's get back on.
Basically, if you disable the num type, you could say.
Exactly. So I could add now anything to this at any time as I get deeper and deeper into programming this program. And with this param, knowing that it's going to be an object, I can now know like what all of the attributes of that object can be. Does that make sense? Kind of.
And you're just setting up in case you don't want to pass in that object.
In case I don't want
Just
to
make a
pass
zero.
in each and every single thing, later I can just like add to that object that's like calling the function rather than like changing all of the function calls, making sure that they all work. Like this like thing can grow dynamically. So all I have to do is just add a new like key, or I could pass these things around to all these other things, and if they don't need it, they won't use it. But they, you know, this will be like my list of stuff that I'm like just passing around the program. Does that make sense, kind of? So all right, so var dist squared equals distance times distance. And you could easily, like, you know, you could easily say, instead of, you know, this, you could just say squared right above it, and just do param distance times param dot distance, right? You don't have to, like, create a new variable just so that you can create a new variable. So does that make sense? Like, this is just like, I'm just trying to show some, like, little things that you can do to make it so that you don't. Sometimes it's good to be very specific and very like verbose, and sometimes it's not. All right, so planet group, because we have this group, dot position, dot set, math dot square root of dist squared divided by 2, 0. So this is x. Oh wait. Oh, whoops. I am doing this wrong. So x is the square root of distance squared divided by 2. And then y is 0. And then z is negative. And where is that going in space? Negative z goes where? It goes into the screen. So it goes further back. Dist squared divided by 2. So does that make sense? So now we're translating it positive x as the square root of distance squared divided by 2, and then negative z, which is basically putting it back farther away, right? What? Oh, sorry. It's basically positive mass square root of distance squared divided by 2 and negative mass square root distance squared divided by 2. And then we're going to say planet orbit group dot add, and we're going to add this planet group. So now we want to make sure that we can manipulate planet group, so we're going to say this, so we're going to add planet group to this instance equals planet group So now we can manipulate planet group from this instance just by calling, you know, like, well, if you want to sit over here, tell you. Okay. Var Saturn, like let's pretend that later we're going to instantiate it equals new Saturn. We can do this, Saturn dot planet group, right? Because of this call right here, we're adding planet group to the functionality of Saturn. So now that we've added that, we'll say var size equals param dot size, or it's going to be 1. So if we put in a size, then we'll take that size. If we didn't, we'll just make it the default, which is 1. And then this dot planet group dot scale dot set size size size. So basically that's just scaling, which we saw the transformation matrix of that. And then this dot planet group. So we're basically doing a lot of different things. Dot rotation dot x equals Saturn tilt. So we'll make this later, this specific thing. And then we're going to do this dot create globe. So clearly this instance slash this class will have the globe, and then we're going to do this dot create rings. So we're going to create those functions in just a second. And then this dot animate orbit equals param dot animate orbit. And this dot period equals param dot period. And then this dot revolution speed. So we're just basically making some like constants and some variables that are now going to be attached to the Saturn class. Param dot revolution speed. And this is just another way of showing exactly what he did above. This question mark is asking, is this, does param.revolution speed exist? If it does, go ahead and pass it, revolution speed. If it doesn't, Saturn.revolution speed, which is a constant that we're going to create. Oh, I'm sorry, revolution underscore y.
Wait, why would we just do param revolution speed or Saturn?
We could do that. It's just showing you a different way of writing it. And this is like, you can write this way in way more languages. Anywhere you want in the world. So this is just like, yeah. Sorry. So that's the initialize function. We're just basically creating a bunch of stuff that we're adding to everything, and we're getting crazy, you know, we're getting fucking crazy.
And we're not putting any other cases for the two
No, so again, he probably coded it like, it's weird, he doesn't follow his own decisions in code, that's why I don't really like using it, but he did make a pretty stellar representation of the orbit system. So we're going to use it. Alright, so we're going to do this, so we're going to create the globe now. What? Okay. No, totally. Do you need to see something specific? Yeah, pull it all. Saturn.revolution. So this is kind of just like saying, setting it up like, hey, this is how fast I'm going to go, and this is where I'm going to go, and da-da-da-da. This is where I'm going to be. This basically is like asking if this front value right here is nil or has a value. So if it's nil, this question mark is going to return false, and it's going to go to the second thing, which is this constant revolution y. If it's true, then it's going to be the first thing. So it's basically first or second. Does that make sense? You'll see it in other languages often, but yeah, it's basically like this is an if statement. Basically, this right here, this part of it is an if statement, and this is true value, and this is false value. Does that make sense? It's nil. Remember, it's nil. So if it's nil, it's 100% of the time going to return a false. Like if it's asked a question, it will return a false. Does that make sense? Cool. All right. So now we're going to make the create globe function, which we've seen many times. Create globe equals fun. And then we'll create the globe by making some geometry, making a texture, and making a material, and then passing stuff on. So we're going to say var Saturn map equals quotes slash images slash Saturn underscore, and then this weird fucking name. I'm just gonna copy and paste it. BJOERNJONSSON Bjarnjensen. BJOERNJONSSON.jpg. Then we're gonna make some geometry like we always do. We gotta make our sphere geometry. Dot sphere geometry. And we're gonna make it 1, 32, 32. So you might be asking yourself, well, why if we scale it to a size, why aren't we using that size on the geometry? Because we only care about making it 1, because whenever we scale it, it'll scale those vertices all at the same time, and maybe we don't want to scale it any. So we basically, it's either 1 or whatever size we want to scale it, and that can be set by us in runtime or before runtime, or at any time. But we want to just make our sphere geometry 1 so that we can use that scale, and it'll do what we think it's going to do. And then let's make a texture equals 3, so not new. Image utils dot load lowercase texture. We'll do Saturn map. And then we're going to make that material with that texture. So we're going to do material equals new 3. What is mesh fong? Anyone? What is mesh fong? What is fong?
Some dude that paints mesh.
Yeah. It's the lighting shader. Yes. Texture. I'm going to pass that texture in as the map. And then we're going to make all of it come together by saying var globe mesh equals new 3 dot mesh. We're going to pass it that geometry that we created, and we're going to pass it that material. Now we're going to add it to the planet group. This dot planet group dot add globe mesh. This dot globe mesh equals globe mesh. Yeah. Cool, so once we're done with that, we're going to make some rings. And then we're going to make an update function. And then we're going to make the ring function, which is great. Look at all this. So that's where we're getting. So the globe was super easy, right? We just fucking made a sphere geometry. Booyah, we're done. But how do you make a ring that's as big as the globe and circles the globe and is far enough away and is a perfect circle? That is the question. Because you don't always need that in 3JS, so they're not going to put that functionality in there. You got to fucking make your own. So we're going to talk about how to make your own. So let me know when you guys are done with that. Go on to create rings. Oh, you're ready? Okay, cool. All right. So Saturn.prototype.createRings equals function and then we are going to var rings map equals quote slash images slash sat ring dot png. Now geometry equals new Saturn dot rings 1.1 comma 1.867 comma 64. So these are magic numbers that maybe we will understand, maybe we won't. He probably, most likely, did the math, just put the numbers in. Now we got to create our texture, but also, you know, take a look. New Saturn.rings is not new 3JS dot anything. This is something that we are going to create, and we are going to hold that geometry that we pass back, that we return from our Saturn.rings function. So var texture is exactly the same way we always do it. 3.image utils. Load texture. We can give it that rings map. And then material, we're going to make it exactly the same way. Material equals new 3.mesh Lambert instead of Fong. Lambert material. The other dude, he's specular, I believe. Or highlights rather. Map, texture. Oh yeah. What?
I said, who wants to make that material?
I know, right? And then, yeah, but Derek material. And then we're gonna do rings mesh. And that'll be a camel case for the first time in a while. New 3.mesh geometry. So this geometry that we're going to get soon. And then material. Just like always. Now rings mesh dot double-sided equals true. So why do we have to say double-sided? Do any of you remember? Has to do with the winding order.
Lighting.
Exactly.
Lighting is inside of you.
Exactly. So there's you can imagine that on the mesh class there's an attribute called double-sided that if you turn it to true, it will make two normals, which will then calculate light from their direction. Does that make sense? Cool. Now we will do rings mesh dot rotation dot y dot x equals math dot pi divided by 2. Correct me if I'm wrong, but I believe that is 90 degrees. Yeah, 90 degrees. 2 pi is 360, yeah. So we're basically rotating x by 90 degrees. So if you imagine it, think about the Saturn. The way that we're going to create it is like this. And so we're going to take x and rotate it so that it's like this. Does that make sense? Because we don't want to, we want to see it like we would imagine it would be in space. So it wouldn't be like this. The rings aren't around, circling around the z aspect of it. We think of here's the Earth and here's the Moon and we're right side up. The rings are like this around it. Does that make sense? Have you seen Saturn?
It's at a tilt.
Yeah, it's at a tilt, but it's basically the way that we're going to create the geometry is going to be like this around z. So we have to rotate by x 90 degrees to get it to where it sits to where we can actually like, oh, now it looks like
We
Saturn.
wouldn't have to do that, but if we didn't do that, we'd have to rotate the whole group.
Yeah,
So the rings look flat as opposed to
like
just
on their
rotating
side.
around.
Why does that have to be created around Z? Why not just create it around Y?
We could, but then we would be using a different
Yeah.
x, y, z, like whenever we were creating. So like right now we have this sphere,
Yeah.
and then the sphere geometry that we're making is first created like this. So you can imagine like if we're out in space and we're looking at it, well then that would look like we were on top of it, right?
Yeah.
So basically they rotate 90 degrees on x, and that becomes the way that we kind of think about it. So now let's do this dot planet group dot add. We gotta add these rings to the planet group. Mesh. And then we'll say this rings mesh equals rings mesh. So we're just adding it to the instance. Just save it away so that we can rotate it. Alright, so now we are going to make our update like always. It's going to be animated, so we're going to update certain features of it. Equals fun. Anonymous function. If statement this dot animate orbit. So remember we got the animate orbit from that params. Go ahead and rotate object 3D. So we set object 3D as planet orbit group up here, right? So now we're saying this dot object 3D, which is the planet group, dot rotation dot y plus equals this dot revolution speed. So remember, oh, divided by this dot period. This dot period. Does that make sense why we do that? And then now you can see that like up here, really quickly, sorry to go away while you're typing, but up here you have planet orbit group, and then you set up all of these scales. So on planet group you set up a scale, you rotate it a little bit, then on here you rings mesh rotation and add it to the planet group. Now we're going to rotate everything as it is right now. We're going to rotate it around its Y. All of the group. That's why we created this ultimate group, which is the planet group. What is it? The planet orbit group. We are now going to keep everything the way that it is. We're not actually changing like the orbit of the actual globe or of the rings. We're just rotating the whole group around Y. Does that make sense? So now, then we can do, you know, this weird stuff. Sim object dot prototype dot update dot call this. So that's just more weird JavaScripty stuff. Saturn tilt, and you don't have to make it like this. He just did. 0.466 is the Saturn tilt, and Saturn dot revolution y equals 0.003. All right, here's the part where I think it's fun, but you might get a little bit lost. Don't worry. As you do this more often, things will make so much more sense. So first we're going to give some parameters. We're going to say inner radius, outer radius, and segments, number of segments. Alright, so if we go up here to this, we can see that inner radius is going to be 1.1, and if you think about it, our sphere geometry is 1, so it's going to be just a teeny bit bigger than our sphere, and the outer radius is going to be much bigger, almost twice as big as our sphere. So you can think about it like, you know, it's now has separation from the sphere. And then 64 segments is how many times we're going to iterate over to make different triangles. And we'll see that in just a second. So we're going to say 3.geometry.call this. So now you can see that we're saying, hey, 3JS, you have a geometry class. I want you to put all of your geometry inside of my baggage. Like all of the stuff that you need for geometry, for you to make geometry, I want to have it inside of this specific rings class. So this is not a function in the sense that it's not on the prototype, right? So you can see Saturn.rings instead of Saturn.prototype. So this is a new class. This is basically a constructor. Rings is a constructor that's constructing 3JS geometry. Does that make sense? So now we're saying this so that we get all the functionality that's inside of 3.geometry, but now we're going to manipulate it in a different way than 3.geometry manipulates geometry. So first we're going to say outer radius, and we're going to do our checks. We're going to say, did someone put anything in outer radius? If they didn't, then let's put a 1 there. Then we're going to check inner radius. Did anyone put anything in inner radius? If not, go ahead and put 0.5 in there. And then grid Y equals in segments or 10. So basically, make sure that you're putting a comma after each of these because we're basically initializing all 3 of these variables at the same time. And then 1 semicolon at the very end. So now I'm getting ready. Var I 2 pi, we gotta have that. We gotta make sure that we know what 2 pi equals. 2 times math pi. And the reason that they do this is because basically 2 times math.pi, it has to like think about that for a long, not for a long time. It's actually very, very quick. But if we just store that value, then we don't have to do that operation every single time we use it, right? So var iver equals math.max 2 or grid y. So math.max is just saying either I want this number or the next number, whichever one is the maximum. that make sense? Var origin. Remember we just talked about origin. New 3 dot vector 3, and then it's 0, 0, 0, baby. So I can define the origin wherever I want, but here I'm defining it as a vector 3, 0, 0, 0. So here we go. For I equals 0, I is less than I ver plus 1 I plus plus. So now we're going to iterate through as many times as we have segments. Does that make sense? Now we got to create these segments. So this is hard. This is a lot of math and whatnot. But basically it's just cosine and sine. So we'll go through kind of what this means as best I can so that you can kind of see what's happening.
Space sensitive.
No, I just put spaces in so that I can read them. Like this could be I ver plus 1 like this. It could be 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 like this. It doesn't care where you put spaces. But I just put spaces so that I can read it easier. Actually, I'm just going to put this back up here. Put space in there. All right, so let's get into this weird math. So I ver I divided by I ver var f radius 2 equals I plus 1 divided by I var. So look at what he's already doing. So remember, actually let me throw up the thing because I'm going to do a little thing on the board. What is it? Photo booth. Alright, so let's turn on this light a little bit. Sorry, yeah. Okay, so already he's showing you that he's jumping. So he's setting up his jump. So he says for I equals 0, so we're starting at the first one. I is less than I var plus 1. So he's jump. So he's going to show you right here I plus 1 divided by I var. So I var plus 1 and then I plus plus, right? So in this very first thing, he's saying I divided by I var, and then I plus 1 divided by I var. Right? So he needs each iteration to make two different distinct things. And so even though he's only jumping one, he's making it so that I will continue until I var plus 1, until it equals I var plus 1. Because he's basically going back around and needs to connect. Does that make sense? So he's going to go around and create each little thing. And if he stopped, then he wouldn't connect these two lines. And I'm sorry, you missed a little bit of it. I go through a lot of the math behind all this stuff, so you can watch it later. But basically, if he just went to I var, he wouldn't connect. So he has to go I var plus 1 to connect, to go all the way back around. To close this circle that we're about to create. Alright, so let's close the little photo booth. Alright, so let's start making some crazy shit. So var fx1 equals inner radius times math.cosine of f rad 1 times 2 pi. So that is the first x1. This is the first x. So now we're going to say we need the y that works with that. So inner radius times math.sine. And if we do, if you'll remember from one of the very first lessons, hold on, sorry, 2 pi. If you remember from one of the very first lessons, whenever you do x equals cosine and y equals sine, what do you get? A circle.
Oh, sorry.
Yeah.
Is it just the side or just the side?
Yeah, so it's like, since they start, like, whenever x is 0, yeah, exactly. They, like, they're opposing. Yeah, they're opposing. So now we're creating our first point. And then we're multiplying it. See, we're scaling this cosine, because remember, cosine is just between 1 and -1. We're scaling it by the inner radius. So that's moving it out by the inner radius. So multiplying by cosine scales it. Does that make sense? Now we've got to create the exact same thing for the outer radius. So we've got to create the outer radius is like point, which is math.cos f rad 1 times 2 pi, and var fy2 equals outer radius times math.sine f rad 1 times 2 pi. So now we have, yeah, exactly. So now we have our, right, so you can see that it's like coming together. It's actually not that hard. It's like, it's just like, oh, I've created an inner radius. So like let's say that my first point is right here. So origin is right here, right? Origin's right there. So I'm multiplying by inner radius, right? Inner radius. To move it out to there, right? Then I'm like from, let's say 1, let's say it's like right there. So that's inner radius. Then I need to make the other point over here, which is, this is outer radius. And now I'm going to move over 1, make this point, and make this point. It's literally, that is as simple as it is. Now I know that I have 4 points. How do I create a triangle between these 4 points? Booyah. It's exactly that. It's as simple as that. Hopefully that seems simple. So let's make that second point. So fx4, what is he doing? Inner radius. So he is actually creating it so that he understands his own index. So even though this would be the next number in the list, f rad 2, he knows that this needs to be 4 to make his indexes prettier, basically. So I'll show you in just a second exactly what he does. 2 pi, and then var fy4 equals inner radius times math dot sine f rad 2. So these are now up against the second points inside of here. And then outer radius var fx3 equals outer radius times. So we create the inner radius point, then we create the outer radius point. And so now you can see that as we're creating this, we're creating it along the z-axis. So that's why we later have to rotate it along the x-axis. So math.cos frad2 times 2 pi var fx, or sorry, fy3 equals outer radius times math dot sine frad2 times 2 pi. Isn't that crazy? He's just making 4 points. Super fucking easy. Now he needs to like put all of those points inside of some vectors. New 3 dot vector 3. We haven't done this in a while. fx1 fy1 0 var v2 equals new 3 dot vector fx2 fy2. Does this make sense? What exactly is going on? And feel free to say no. It does not?
No.
Okay. How about to you guys?
I follow the in and out radius, and now you're putting it on faces? Like
No, vectors. So these are just storage devices.
You're passing the vectors through the dots? Is that like what's happening? Like
No, well, vectors are just points. So we created each point individually, and now we're making a vector out of those individual dimensions.
So is that what we drew in the beginning of class?
Yeah.
That's why you went 4-3.
No, so here, let me finish typing this really quickly, and then I'll show you exactly what's going on. fx4, fy4, I misdid this, so there should be a y, 0. So we've now done the math for our points, right? So let me, oh God, I'm on it. Oh, I hate this. All right, so in essence, what we're doing is literally like this. Yeah. Yeah, this is recording. Well, I mean, not this, but this should be recorded. Yeah. Okay, so let's make this a little bit easier, right? We want this type of primitive, which is basically just a quad or like a billboard or whatever. We want to put 4 points together and create a box, right? We have to do that. We did this at the very beginning, right? We created 4 vertices that had 0, 1, 0, 0, 1, 0, and 1, 1, right?
Yes.
So that's our vertices. So the way to programmatically create these vertices is to say for y equals 0, y is less than however many of these we want, 480. We'll just think about it like a television. y plus plus, right? So the way to do this programmatically and then create the x. X equals 0, x is less than 640, x plus plus. So the way to do this is the first one is going to be 0, 0, right? So all we have to do is say 3 dot vector 3, and then say x, y, right? Or, I'm sorry, vector 3 is in, and then 0 for z, right? So the very first time through this thing, y is 0, x is 0. Perfect. That's exactly the point we need. Right? Now, we need another one in here because each of these 4 has to be created at the same time so that we can keep track of the indexes. Right? So what we'll have to do is we'll have to say, well, let's add 1 to x. So 3 dot vector 3 x plus 1. Actually, I'm going to go, I wanted to start from here, just, yeah. We'll just pretend that this is the correct winding order. It's a little bit weird to get in one, but. So x plus 1, y, which is 0. So now we have the second point because we're still in this for loop. So now to create this point, we do 3 dot vector 3, and then we do x because it's 0, and then y plus 1 because it's 1, right? We moved up 1. So now 3 dot vector 3.
X plus 1 and y plus 1.
Yes, x plus 1 and y plus 1. All right, now, so basically that's all we've done here. If you look, x1, y1, x2, y2, x3, y3, and x4, y4. We just created 4 x's and y's in a circular motion because we're doing sine, which basically says cosine of like the angle, which if we're talking about an angle, like it's the radians are always going to be around a circle. So if this number in here, if this number were like 900 million, right? That number is still somewhere on this circle. This is just a radian, so it's going to divide by whatever, and it's going to return whatever. It's going to return a number between 1 and -1, right? So now we're going around in a circle because we're doing cosine of x and sine of y. So we're going around in a circle, then we're multiplying that by inner radius and then by outer radius, right? So we're basically creating our first xy right here and our second xy right here because it's bigger. Remember, it's 1.87. So we're multiplying like our number between 1 and -1 by 1.867. So that's going to go out here. And then we're doing the same with this one. So it's going to go just a little bit past the sphere, right? And then we're moving over 1. So we've gotten these 2 points, right? Inner and outer radius. So then we're moving over 1 and creating these 2 points, which will basically create our rectangle. Does that make sense? And now, the cool thing is that we'll see how he indexes. So like, the indexing will work programmatically in any way that you do it. So let's quit this.
I think
You still don't get it?
I mean, I got it to the point that you started talking about the radius and things like that.
Okay, so remember we have inner radius, right?
Yeah.
So if you take for granted that sine will always, no matter what you pass it, give you a 1 to a -1 value. So it could give you a 0.96, but it could not give you a 1.3. Does that make sense? It will never go outside of 1 and -1. So if I multiply that by a number, I basically scale it. So I scale it in an exact way of how much I want the radius to be. So now I have an inner radius and an outer radius. The inner radius is 1.1, so it's going to scale just a little bit past the sphere. And the outer radius is going to scale it much larger than the sphere. So now we have 2 points. So now we have 2 points that are going in a circle, following each other. Does that make sense?
Wait, sorry, I was confused that last part you were saying about we'll multiply the inner radius by.
Yeah, so look up here. So inner radius times math.cosine f rad 1 times 2 pi. Don't worry about what these are. These could be any number in the entire world. It's still going to produce, if we increment it, it will still produce values around a circle, basically. So now if I multiply the cosine and sine, which is a point on the circle, by an inner radius, it's going to scale that 1 to -1 number that I get back from sine and cosine by that amount. So it's going to push it out from, being like a very small circle. Does that make sense? And then we do the exact same thing with the exact same number, but multiply it by a bigger number to get the outer radius point. It's basically, remember our sphere is 1.
Yeah.
So the inner radius is 1.1. So it's just 0.1 bigger than the sphere. The outer radius is 1.867. So it's almost twice as big as the sphere. Does that make sense? So basically we're creating this one the first time, right? Inner radius. And then we're multiplying it by outer radius instead. So it's going to project in the exact same direction. So it's going to create it like this. And then we're going to move over one segment, which will increment the clock, basically, like a minute hand. Does that make sense? And then we're going to multiply by inner radius, and then we're going to multiply by outer radius. So we're making fx1, fx1, fy1. This is fx2, fy2. This is fx3, fy3, fx4, fy4. Does that make sense?
That makes sense. What's F?
So frad is basically, like, it's saying up here, we created this by dividing, how did we create this? Fx, oh, right. So we divide it, so up here we created ivar, which is basically the how many segments we want, and then we're dividing that by what number we're on. So we'll basically come 100%, but we want to go one more to connect the dots. Does that make sense?
Cosine and sine of an angle, and if it was just 2 pi, then all the positions would be at the same angle. So to increment that angle and make it a full circle, you have to segment it.
Yeah.
Or divided by 1.7.
Yeah.
So it's like kind of like 360 divided by.
Yeah. Cool. So now we got to add these vertices. Vertices.push. This dot vertices push new 3.vertex. Oh wait. Vertex. And we'll go over what vertexes are, because you might be like, why are we creating a vector and then putting it into a vertex? You could put a lot of things in a vertex.
So it takes all the data?
Yeah, it takes all the data. This dot vertices dot push new 3 dot vertex v2. So we're basically just adding these vectors on. We have the position data that we need, and we're adding these as vertices to the object, which is rings. Dot push new 3 dot vertex v3 this dot vertices dot push the last one new 3 dot vertex v4. Alright, so here's where it gets nutso. It's motherfucking nutso. Motherfucking nutso. So now we're done with this for loop. We've got all of our vectors, all of our vectors and inside of the vertices in this one for loop. It's going to put all the position data into our vertices. Boom. 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 Yeah. Alright, so now we're going to make another for loop. I equals 0. I is less than I var. So now we're not going to go I var plus 1. We're just going to I var. And then now we're going to push some faces. This time, face. You alright?
It's a little dark.
Yeah, you alright there, boy? Alright. 3 dot face 3. I times 4, I times 4 plus 1, I times 4 plus 2, this dot faces dot push new 3 dot face 3 I times 4 I times 4 plus 2 I times 4 plus 3. Oops. Are you guys bugging out yet? By how fucking brilliant this is? So brilliant, dude. This is so brilliant. Mathematics is motherfucking crazy. Alright, so write that down and I'm about to blow your mind. I'm about to fucking get nuts out. Oops, sorry. Okay. What? Oh no, I'm recording. I'm recording right now. I've been recording the whole class. Alright. So, let us pretend that we understand completely that around the circle we've created these points, right? So let's pretend that this is just the first time through that above for loop, right? So we have, V1, V2, V3, and V4, right? We have those 4 vectors pushed onto the vertices and created. So now, what do we do in this first for loop? We're saying for x or whatever I equals 0, I is less than I var. Remember earlier we said I var plus 1. And then we're doing I plus plus. I can write it. I plus plus. So now we're saying face push. Let's say, let's pretend that I'm writing. Face push. And then new, I'm not even going to write all the other stuff. So I'm going to just focus on the numbers. So the numbers are face 3, I times 4, I times 4 plus 1, I times 4 plus 2, face 3, I times, what is it? I times 4, I times 4 plus 2, I times 4 plus 3. So, if we are to believe that we have actually created these vectors, and that these vectors are actually the things that will create the geometry of the sphere, if given around, all the way around. Basically, what we're doing here is saying the first time through, let's just go through. The first time through, it's going to be 0 times 4, 0 times 4 plus 1, 0 times 4 plus 2, 0 times 4, 0 times 4 plus 2, 0 times 4 plus 3. So basically what it's going to do is it's going to say, here's the 0 point inside of the array, and it's going to say, here is the 1 point, then it's going to say, here is the 2 point, right? So it's going to draw this, then it's going to say 0 time, well, I might have them out of order, but...
No, you don't. It's 0 to 3. You just got it for 1. That's all.
Wait, what?
You wrote 1, 2, 3 instead of 0, 1, 2, 3.
Well, but then it would make it.
Ah, okay.
Yeah, it should be.
Okay.
I think it's probably like this. Maybe V3 is like this. Oh, right, because he flipped them earlier. So V3 is there. So it'd be 0, 1, 2,
Yes.
and then
0,
0, 2, 3.
Exactly,
Now next time through, it's gonna jump to 4 because it's already done 3.
Yeah.
Right? It's perfect. It's beautiful. And then it's gonna be 2. Booyah. Booyah. Isn't that crazy? Does that make sense?
Wow.
It's pretty fucking insane, right?
That's good for triangles in any linear
That's
array.
trying-
Just
Yeah, exactly. It's literally for anything.
It's gonna always be that.
Yeah, it's always gonna be that way.
Oh my god.
Every triangle is exactly created like that, no matter what the fucking position is. If you create 3 points, if you create 4 points, you can connect them in, like, if you create 4 points anywhere around the city of New York, you can connect them in exactly that way, and then you can see something. Now, make sure that the winding order is correct, but that is basically the winding order. Does that make sense?
Yeah.
I mean, it kind of actually, it's not necessarily the winding order, but always. But like, whoa, that is how you can make any type of geometry. Just connect them in that exact order, or just know the order that you want to connect them now that you understand, like, oh, when I make a point, and then another point, and then another point, and then another point, I know that I need to connect them in a specific way. And that's it. There's like literally no magic to it. It's just, well, actually, I think it's very magical. But yeah, no, totally. All right, so now I'm going to blow your mind even more. We have we have basically some, we're going to have to make texture coordinates. Texture coordinates are super duper easy. So we're going to say this dot face vertex UVs 0 dot push. And then we're going to make an array here. New 3 dot UV, both capital, 0 comma 1. This is an array. This is an array. New 3 dot UV 1 1. Oops. 1 1. Kind of following a pattern, right? New 3 dot UV 1 0. What is that creating right there? Or starting to create, rather. 0 1 1 1 1 0, and then on this next one we're going to say yeah. It's exactly the same. .uv. Now I got to make the other side. Comma. New 3 dot UV 1 0. New 3. Oops. UV 0 0. Yep. Yeah, so I mean it's literally like you are putting texture coordinates on this point, this point, this point, and this point. So the first one is 0 0, or rather here's where 0 0 is. This is 0 1, and this is 1 1, and this is 0 1. And maybe it's like this. Maybe it's something like that. Right? So 1 1, 0 1, and 0 1, or sorry, 1 0 are on 1, and then the other one is 0 1, 1 0, and 0 0.
Crazy.
So texture coordinates are just the same.
No, wait, I've got I'm thinking I was doing the same
Kind of.
question, but I wasn't. And why did we just start at 0 0? Like, why did we start in...
Because
Like,
it's
I see.
it's basically we'll go into it a little bit more deeply, but what later. But what is going to happen is whenever, like, let's say that these 4 positions, these 4 vertices are processed in the shader, there's only going to be 4 vertex shaders that fire, one for each of these. And so we put in vector information. We've also put in texture coordinate information and how to connect them. So basically, whenever it's inside of the shader, we're going to pass, like we're going to position these vectors in wherever we want in space based on like our projection and model view matrix, which we'll talk about soon. But basically, we'll take that matrice and we'll like move it and we'll scale it, make it bigger so that we can see it. And then it will only produce 4 vertex shaders. And whenever we go out of the vertex shader, it will then interpolate all of the numbers in between here. So it'll be between 0 and 1. It will be like 100 million, like, you know, as close as it possibly can get to the floating decimal point precision between 0 and 1. So when we put these on each triangle, we're basically saying, like here, I don't really want to think about how you're going to like put this texture on. You do the math. So you're saying, like this one has, like this one starts from 0 and goes to 1. The next one starts from 0 and goes to 1. So you kind of figure out like how you're going to spread the pixels around you. Does that make sense?
It does. The only question I have.
It'll make a little bit more sense as we get further.
It kind of does. But the only difference, the way we got this one, like, till now we were looking counterclockwise, right?
Right, yeah.
And this one, it was like.
You can build it either way.
And then, like, it was clockwise and then counterclockwise,
Right.
right?
I'm not totally sure. I mean, it wasn't counterclockwise.
1,
It shouldn't have been counterclockwise.
No? Okay,
Yeah.
maybe I was.
It should have been counterclockwise because GL wants it counterclockwise.
But here it's clockwise and then counterclockwise. It's 0, 1, 1, 1, 1, 0. And
0,
then it's
1,
1,
1, 0.
Yeah, and then it's 0, 1, 0, 0, 1, 0. So I'm like,
Oh,
so,
right.
like that's where I'm lost in the pattern.
Right. Let me do a
Make
little
a
bit of
difference?
research on that specific thing because I'm not sure why it's doing that either.
If it doesn't matter, don't. But
No, it does matter. I want to know and I want you guys to know because I think that it's very important.
Okay.
Because here that would be going clockwise.
What?
With this would that be going clockwise?
Yeah. I think that's what I need to research just to make sure. I mean, basically, it shouldn't be clockwise. It should be counterclockwise because that's the way.
Is it because that you flipped it?
Oh wait, no, it's also double-sided, so it actually doesn't matter. We said double-sided,
Okay.
so it doesn't matter.
Winding order.
Yeah, winding order doesn't matter because both sides will be able to see. Does that make sense? We said up here. Check it
I
out.
remember double-sided but
What?
Well, both sides then are gonna.
okay. So
Are going to be
that-
shown.
Yes, okay. I get
Yeah.
it, Okay.
And then you're gonna make
Yeah, exactly.
Yes. Okay.
So basically, winding order doesn't matter in this specific thing, as I understand. But let me also read up and check because I should know that by now. Now we're gonna say this dot compute centroids. Don't worry about that, and this dot compute face normals. Don't worry about that either. And we're gonna say this dot bounding sphere equals radius outer radius. And then we got to make some Saturn ring stuff. Saturn dot rings dot prototype equals new 3 dot geometry and Saturn dot rings dot prototype dot constructor equals Saturn dot rings. So we're just telling it like this is the function. Normally we don't have to do this, but we chose to show this functionality as well. So again, a million different ways to do things in JavaScript. None of them quite pleasant. Let me see if...
Didn't someone have to declare like a return when you wrote say returns?
What?
You never have to return this geometry at the end of this function? Someone, or I guess it is a geometry.
No, we are basically making a new... Yeah, geometry is us. So geometry gets...
It's not a function.
Exactly. I misspoke. Yeah, I misspoke. So right up here, whenever we say this dot geometry dot call this, it becomes geometry. So whenever we pass ourselves back after the construction, basically. Yeah, no, I totally know what you mean, boy. I goddamn totally know. Okay, so Unfortunately for us, he continues on and isn't like, why don't you take a look at Saturn? So we're not going to be able to easily put this onto our browser. If you want to see what Saturn looks like, go ahead and open it up. But we have the Saturn.js, and we're going to basically continue building stuff. And by the end of our class, we will have like this entire solar system completely built with all the shaders and all the cool shit and everything that's going on. Does that make sense? All right. So if you want to see it, you can take.
Couldn't you include the Saturn.js in the Earth one and then not draw the Earth, but draw Saturn instead?
You could, but I think there might be some pretty epic rotation going on.
Oh, that's right.
So we would just have to take that rotation out, and then.
Be rotating like.
Yeah, no, I mean, but we could totally do that. I have no problem doing that. If you want to try to, Okay. 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 So yeah.
Awesome.
But this week we're not posting.
I mean, nothing besides your midterm.
Double-sided, is that built into geometry?
Yes.
Wow.
Yeah.
Wait, and our midterm is just
Well, it's just, I mean, it's relaxed. We just want to, I just want to do some stuff on the splash page, basically. So just like think of, I'm going to implement it. You just create whatever you want to create, and I'm going to put it inside. Yeah, so just like look at the examples. I would say like this is the best moment that you could possibly check out 3JS examples. Right now is when you are most alive and on fire with the knowledge of God. No, but I mean, I make a joke, but like right now you